golden balls?
The golden balls.
So the guy is explaining it.
Abraham, Nick, you have 2 final golden balls in front of you, and they are the most important golden balls of the game. You each have a golden ball with the word split written inside. You both have a ball with the word steal written inside. You will know which is split and which is steal because you can have a look. If you both pick the split ball, you split the 13,600 and you go home with 6,800 each. If one of you chooses the steal ball and the other chooses the split ball, whoever chooses the steal ball goes home with the whole lot, 13,600. But if you both choose the steal ball, you leave today's game with what you came with, nothing. It's the ultimate test of faith, trust, and let's face it, greed. Take a moment to look at the balls in front of you so you know for definite which is split and which is steal, but obviously keep them concealed from each other. Just have a look. Okay. It's the easiest choice, but the most difficult one. What I want you to do is to spend half a minute talking to each other about what you both should do. Nick? Abraham?
Abraham, I want you to trust me. 100% I'm going to pick the steel ball.
Sorry, you're going to...
I'm going to choose the steel ball.
You're going to take the
I
steel.
want you to do split, and I promise you that I will split the money with you.
Well, after you took the steel.
Yeah.
You're going to take the steel.
Yeah.
I'm going to take split.
Yeah.
So you take the money.
And I will split it with you.
After the show.
Yeah. I promise you I'll do that. If you do steal, we both walk away with nothing. I'm telling you 100% I'm going to do it.
I appreciate that. Right, I'll give you another alternative. Why don't you just both pick split?
I'm not going to pick split. I'm going to steal. Abraham, honestly, 100% going to steal.
It's in your nature to steal.
No, I'm honest, and I'm going to tell you.
You're honest.
I am. That's why I'm telling you I'm going to steal. If you do split, then I will split the
I
money.
can't see myself doing that.
Okay, well I'm going to steal, so I'm going to leave with nothing.
Where's your brains coming from? I can't work out.
I know that I'm a decent guy, and I will split the money with you.
Well, we should just both split then.
No, I'm going to do steal.
There is no legal
I know there is. I know there
for
is.
him to give you the
Of
money.
course. If I gave you my word, now let me tell you what my word means.
Okay.
My father once said to me, a man who doesn't keep his word is not a man. He's not worth nothing. Not worth a dollar.
I agree.
So,
Abraham, I'm going to steal. So you've got a choice. I'm going to steal. I'm going to both walk away with nothing. Because you know, I've told you my intention, and I've told you that I will split the money with you, Abraham.
if I gave you my word that I was going to split, I would split. And you're going to take steal. So,
The only way you can guarantee to walk away with 6,800
it's by
is to
sharing.
guarantee that you both put the split ball in. And I do now have to push you for a decision. It's a tough one.
We've lost it. We've lost
Okay.
everything.
Class then.
We're walking away with no money because you're an idiot.
No, that's not.
This can go on all night, and these people have got to get up for breakfast. Nick, choose split or steal. Abraham, choose split or steal. Now, please. Choose a ball.
Right, I'll tell you what I'm going to go with.
Okay.
I'm going to go
I
with.
promise you I'll steal.
You cannot change your balls now. Split or steal? Yes! Congratulations, you're both split and each received 6,800.
So I think it's kind of interesting, like how they go back and forth, and he's going from like you have to trust me, to somebody who doesn't keep his promise is not a man, and then like you're an idiot and stuff like that. In the end, they come together. I think it's a kind of cool interaction that we just observed. I think one of the groups a few years ago, they chose this game as their like course project, and I just saw this video on Reddit this morning, so I thought I'm going to show it to you. So what they tried to do is they looked at the interactions before the decision and tried to identify if the individuals are going to split or going to steal afterwards. And I think Sue is working on this project or something similar right now with John. No, the split steal thing? Yeah. Yeah. So yeah, John Gratch is probably talking about this a bit more when he's going to give his guest lecture. All right. So just to recap a little bit, we talked about human communication. We talked about the individuals and how we convey emotion, affect, personality status, etc. through our facial expressions, our gestures, our posture, even the clothes. We talked about the facial expressions, the action units. We identified that there is kind of like a common language to talk about facial expressions, to code them. We then talked about the audio, and this is basically going to be the main topic of today. We're going to go into all of these points, in particular prosody and the voice quality aspects of the voice, and we're going to kind of realize in a little bit that people have tried. A guy with my last name, he has been working all his life on coming up with a common coding scheme as for the facial expressions for the voice, and I think he got somewhere, but obviously it's not that, it's not the same for voice and facial expressions. The units aren't that clear. You can't just separate and say this is this, this is that. So there's a lot of blending going on, and I think you can't really look at both concepts, the prosody and the voice quality, separately. They're kind of superimposed over each other. They're blending into each other, and we're going to see a couple of examples on that. Then we talked about gestures and posture, etc. We went on to the dyad. We asked a couple of questions okay, so what can we read from the dyad? What's the relationship? What's the conversation like? Is it an engaging conversation? We just saw another dyad, in a sense, with an annoying third moderator that tried to, separate them with there is no legal obligation that he has to steal with you after the show and to split with you after the show and stuff like that. So I just wanted to strangle that guy. So that was kind of an interesting three-way conversation with the main dyad that was going on there. And clearly they didn't know each other before the show, but they kind of created this communication, they shared a lot between each other. They exchanged thought process, and they tried to convince each other through certain means, and I guess we know who was the dominant person that convinced the other guy to split. We looked at a couple of these behaviors and what it's good for, also the coordination of the conversation. This is going to be what we're going to talk before we're going to talk about the voice, because I forgot to go through those slides last Monday. All right, then we talked about groups, and we had this interaction, this interesting group interaction.
It's very embarrassing. You told no, I don't know how to call you.
Yes. Oh, just go sensei.
Okay, yes, that's But if they are not sensei, you can't just say son. Oh.
Okay, they're not going to start again. That's good. And I kind of like this sort of representation because it quickly shows you, in a sense, like who is speaking when, and it's really like it shows nicely the fragmentation of how humans communicate, and in a sense also when individuals come together. And I think one of the things that I feel like I want to teach is, you know, interesting ways of like representing information, like data visualization, these kind of things. And I mean, I think data is beautiful. You know, like there's this I think online blog that it's out there. Like data is beautiful, and the visualization of data, and to be able to learn from it, I think is quite cool. All right, so let's go to human communication, and I think the this fragmented block representation is in a sense a good segue to this, because and here we're going to just talk about dyadic communication, but dyadic communication can be quite complex, and like on a very simplistic basis, this one guy here has a plan to basically talk about this tree that he saw, this beautiful tree, and he wants to convey this information to this interlocutor or interactant, the person that he's talking to. And what he has to do is he needs to like code whatever is going on in his brain into acoustic waves that this guy then can perceive with his ear, and in the brain then on the receiver side this needs to be decoded. And the problem is that a lot of stuff can go wrong here, 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 and everywhere, and really like you can break it down to almost like an information kind of theoretic ground, where on the one hand side you have a source, like the thought, you need to encode this message, you send it over noisy channels, you need to decode this message, and then you need to receive it. And if you had some bad conversations, you know that a lot can go wrong on many issues. So for example, it can be very loud, it can be that you talk across each other and not like with each other. There might not be, you know, like the shared perception is not there, but and we're going to talk a little bit about like what all can go wrong here. One way to look at this communication in an interesting way as well is the Brunswickian lens model, where basically you have some physical or social environment or some representations that are being translated over this called cues, so that the observer then can make an observation and an assessment. And this model is being used a lot in like physics and everywhere, and I think we can use it also for our human communication domain, where basically these cues could be different kind of things, like for example facial expressions or gestures or the posture, and even the voice or the verbal content, the information that we convey. But one of the things that these cues have in common in both these physical experiments but also in the social experiments is that they are uncertain. You don't necessarily know the one-to-one, the clear relationship between this eye twitch and the emotion or the intent or the target or the meaning of this message. So this is, it's not like a unfallible communication. So these cues have uncertainty and uncertainty associated with them. In addition, the same cues can be used for different things. So you can have a smile that means that I'm happy. You can have a smile that means that I think what you just said is funny. I can have a smile that just is a nervous smile, and I just smile at you because I don't know what else to do. And so this is like, there are many different kind of smiles, and really to disambiguate all of these cues is quite difficult. And one of the worst things for multimodal machine learning is also that often these cues are redundant. It's bad because, like, we can't learn from the diversity. We talked about this last Monday, but also it's kind of also, it's good and bad in that sense, like, because if it's redundant, we can live with losing one of them and understanding the other one, but we want to have these messages to be quite diverse, so that we can disambiguate information better. All right, so let's look at an example. Here I colored these cues to signify that these are from different modalities. So on the one hand side we have the expression of anger. This kid shouts, so his posture changes, the voice is loud, and the facial expressions have changed. And then this guy, he's perceiving the anger through these different channels, and the channels are the following. So we have vocal cues in blue, so that could be the loud voice and the high-pitched voice. Facial expressions are like it frowns, and like the eyes are closer together. And then for gestures, clenched fists and like shaking posture, like you can see this through these little dashes there. All right. But the important issues here are, for example, that you need to be able to measure all these cues, and they need to be identified a priori, because otherwise, if you're not looking for them, you don't know what to look for. So that's kind of like an important aspect of this. And as we mentioned, there might be inconsistencies on both sides, and the coding might not work because he's so angry that like he forgets to really like bring along the message. And also this guy might get so nervous or anxious that he doesn't understand what's going on anymore. So there's like a lot of things that can go wrong. And one of the funniest things, I think, is that the cues that are used on the one side might be different from the ones that are on the other side. That can be due to all sorts of things. For example, culture. Is that me? What's going on? No, I just switch up those guys. All right. So yeah, so these the cues might be differently used on either side. So, and there's one of the, what is going on? So it's not enough to switch off notifications for this. This happens when you have friends texting you in the morning at 8:30. Okay, so. And so one of the interesting models that where I think it becomes quite clear how cues can be used different ways on both the sender and the receiver side is this four sides model, or in German we call it the four-ear model from Friedemann Schulz von Thun, which basically has four sides in the self-revelation, the factual information, the appeal, and the relationship side, and I like to talk in the factual information domain, and some people might rather talk in the self-revelation domain or in the appeal or the relationship domain, and how one message can be decoded in different ways. I got an example for that. So the sender says, there's something green in my soup. So the factual domain, obviously, there's something green in the soup, right? So that's how they could talk to each other. But the self-revelation side, in a sense, says like, I got no clue what that green thing is. So I don't know what the green thing is. The relationship side is, well, you cooked it, you should know what it is, right? So can you tell me? That is the appeal side. Tell me what it is now. And then the receiver perceives, well, on the factual side, the one communication side that I like to communicate on is like, there's something green in the soup. The self-revelation is, you don't know what the green item is, and that makes you feel uncomfortable. Well, that's not a bad one too. But the relationship one is, you think my cooking is questionable, and I think you already know where this is going. Where the appeal then, I can only cook what you know in the future, and then the communication in a sort of breaks down. Well, the actual response will be, if you don't like what I cook, you should cook yourself. So, so this is kind of like an illustrative example of like how this kind of communication can go wrong, and I mean there's a lot more to these kind of human communication models, and if you're interested, you can go into a bit more details on those and like investigate what you can find. But we're not gonna like go into deep depth with those, because in the end this is going to be really hard to model automatically as well. But I'd like to show you a couple more examples on like how humans communicate, and just to show you a little bit of the different views. So do you think that humans communicate like this, like in a like speaker listener, speaker listener, speaker listener, or like, you know, like a nice back and forth? Well, I can tell you they don't, and again I'd like to show you one example. It's like they don't, right? So it's a lot messier than just this back and forth. There are no like clear defined boundaries of turns to talk about turn taking and like to give the floor, etc. Is a bit too abstract. I think if you look at a lot of the data, you can see that human communication is a lot messier. So it's just kind of like a word of caution. So to, you know, to take care, or like to be able to handle this kind of stuff. And I think human communication looks a lot more like this, where, you know, like it's a feedback kind of loop where both become speaker and listener at the same time, while one might speak actually, like send verbal information, the other one might send back non-verbal information. And in the end, the communication model will probably look a little bit more like this if you consider it. So you have source and receiver at the same time on both sides. You're sending messages over channels. You also receive feedback, and you do that basically at the same time on both sides. This is all influenced by a whole bunch of noise that could be of different qualities. So, for example, you can have like a bus drive by you. You can have physiological noise, like you might not be able to hear that well, or you might have psychological noise in the sense that you're just really furious or really nervous because you're going to have to write an exam in an hour. And there might be semantic noise where you don't really know what the other person is talking about. You haven't read up on the issue or something like that. And this all is influenced, kind of like, I put it up there, like this context word is influencing kind of everything, where context can be really a lot of different levels of additional information or additional influences, like the location, where and what time this is, the communication. Like you might be looking at interactions from the 18th century. They might look a lot different than what they look like now, or nowadays everybody's staring into their phone. So now human communication looks a lot different, and cultural context also plays a big role. And then lastly, a little bit of competence, like some people might be really good at communicating, some people might not be. And then we talked about how we are then now trying to get at all these cues and understand these different types of concepts, like disorders and social domains and then affect or emotion. And then we moved on into the challenges of machine learning, and we introduced this kind of temporal or like complexity model, where on the one hand side we try to like first of all like get the data from all these sensors, identify our cues, combine the cues. This is kind of like associated with the lens model, and then we try to interpret these cues. So you can like see this along the lines of what the Brunswickian lens model looks like, or how human communication like feeds into this kind of model. And this is kind of where we're going to focus our course on, like mostly. All right. So are there any questions to the first lecture, because we're going to go into the vocal messages now? No. Okay. Good. So yes.
What's a priori? You just mentioned it's
A priori.
yeah.
The term is used differently. Like in this context, it was just basically you need to know this a priori means like before the communication happens. So you need to have defined that before.
Knowledge beforehand.
Right. Yeah. And so, for example, in statistics, you have the a priori probability of a class in like if you do machine learning with probabilistic models. Like sometimes, like if you want to do, I don't know, like yes, but like I'm looking for a task like laughter detection or something like that. So you have a conversation that consists of 90% not laughter but 10% of laughter. Then you want to feed into this model your a priori probability of having laughter, which is 10%, and the a priori probability that you don't have laughter, which is 90%. So it's kind of like this, say, some prior knowledge that you can derive from, like, I don't know, like rules, your data, and so on.
So information from two channels conflict with each other. What should you decide?
That's a good question. So if information from channels compete, I think there are multiple ways to deal with this, and I think we're going to talk about this more during the class. But so one of the nicest ways to deal with this is like if you trust one channel more, you just take that one. But sometimes you don't trust them more, like you mistrust them equally, so to say. And then it becomes interesting. One of the ways that I usually like to deal with this is I like to postpone decisions. So, and this is also one topic that we might get onto in the course, which is fuzzy machine learning, where you don't make the decision right now, but you make it at a later stage. So you kind of define your posterior probability, which is the opposite kind of like of an a priori probability, I don't know if there's a pen somewhere. Here. So, so if you have some input into a classifier, and I really hope that this is also erasable. Yes. I'm just drawing on the wall. So you have a classifier here, and then you would want it to say 0 or 1, like yes, there's a laughter, there, no, there's no laughter at this stage, but this classifier is the visual classifier, and then you have the audio one. And so let's say this guy says this guy says actually 1, and this guy says 0, and you don't really know what to say now. It's like, okay, so one says 0 and one says 1, I don't know what's going on, right? But if you actually look at maybe the posterior probabilities, and it says 0.2 no laughter, and 0.8 there's a laughter, and this guy says 0.55 there is no laughter, and 0.45 there is a laughter, then you can see kind of like that this guy is a lot more uncertain than this guy, right? So you might want to then kind of trust this one. So what this kind of means is that you don't make a decision at this level, but you make it at this level, and this kind of like makes it a little bit, you postpone it a little bit, but you can think of like postponing this decision further and further, and to work with these kind of posterior probabilities or membership assignments, whatever you want to call them, you have a lot more flexibility. You can correct for your errors at the later stage. So that's kind of like a high-level response to your question. I hope it answered it more or less. Cool. Any other questions? And we're going to talk about this a lot more later on when we're getting to the multimodal machine learning. Okay. I just realized do we have September yet? No. It's not September. What am I talking about?
We got a whole week.
Almost though.
Yeah.
We just act like as if this lecture was like next week. So okay, for the outline of the course, we're going to talk about like how we can use our voice, how we can use our speech, some fundamentals like about the production of speech, the perception of speech. We're going to talk about like different meanings of sentences that are manipulated in different prosodic ways. And then we're going to talk about some vocal expressions like laughters, back channels, and we're going to talk about voice quality. Some learning goals, you can look at those later. But I'd like to start off with a nice kind of quote where it feels like, I think it sums up nicely what the voice can do, and so a story is told as much by silence as by speech. And it's not only silence, but you could replace this with prosody, voice quality, the facial expressions, etc. So the I would just kind of convey the idea that human communication is a lot more than just words, and I think this course is trying to give you a good overview of like how much more it can be. So the voice, the facial expressions, etc. have a lot more to do. So, and some of the multi-layer characteristics of the vocal messages are the following. So you have the linguistic layer. So yes, I am conveying information about what I'm saying through words, and there's some language, grammar, phonemes, parts of speech going on. But really, this is not much different, even though it's a lot more flexible and a lot more error-prone than in written language. It's not really going to be what we're going to talk about mostly today. We're going to talk about mostly about the paralinguistic layer, so something that is not linguistic but still conveys a message, it conveys information about your emotional state, and so on. And then there is also lastly an extra linguistic layer, which we are not going to talk about, but this extra linguistic layer basically also identifies speakers by age, gender, etc. So men are usually taller, that means that their vocal tracts are larger, that means that their voices are resonating at lower frequencies, which means that the average pitch or the frequency range is lower and so on. So there's differences in gender, and there's differences in age as well. So like, for example, kids speak with a lot higher voices than adults. All right, so let's go into the fundamentals of speech productions, or speech production and hearing. So first we're going to talk about some speech production, the anatomy of the vocal tract and phonation types, perception of speech, and some basic measures. And in the basic measures, I'd like to introduce two different kinds of ways to look at it. Oftentimes, like if you read a paper and people write about the pitch, and then other people write about the fundamental frequency, and then you read another paper where it's about speech intensity, and then the other paper writes about speech loudness. And often people are thinking, okay, well, it sounds the same, looks like the same, this is going to be the same. But they're not. They're not the same measures. So there are conventions about pitch and fundamental frequency. Pitch is something that is perceived, so it has a perceptual component to it, and fundamental frequency is the actual frequency in the physical domain, so it's just a physical measure. The same for loudness. You can imagine, okay, loudness is something, well, it has the word loud in it, and so that is a perceptual domain example, whereas intensity is usually written in decibel, and it's an actual physical measure. I like the physical measures more because they are not influenced by the perceptual abilities of individuals. Some people might have hearing problems, etc. So, and then they might talk in a different way. So I'd rather look at the physical measures, but we're gonna basically touch upon both in a sense. All right. Yes.
So like, what's the metric of perceived like pitch and loudness? Like, if you're using dB for intensity, then what would be the just loud?
You would use you could use decibel as well, but then you would have to factor in, and we're going to get to this. You're going to factor in the perceived, or the human's ear's ability to perceive certain frequencies. So if you have like a high decibel signal in, I don't know, 40,000 hertz, right? This signal will be perceived as a lot more quiet, if at all, perceived by the human ear, because this frequency is so high that the human ear either doesn't hear it probably doesn't hear it, by the way, and so that measure will be very small in comparison. Whereas if, it's kind of interesting because I guess evolutionarily this can be explained, but we hear a lot better in the range of like where speech is usually like at, rather than, you know, high frequencies or very low frequencies. And so the human ear, or like maybe, I don't know, this is kind of like a chicken and egg problem, like did we develop voice or like the speech into this domain so that we can hear it better, or did the ear adapt to that quite well, but I think it's more that we adapted to the ear's ability. Well, yeah, I can show you later, like how these curves then look like.
So do we only use the physical measures for the calculation purposes?
I would suggest so. Most of the like feature extraction toolboxes, etc., they would produce like the physical measures. Yeah. All right. So speech production, basically, unfortunately, it's a bit of like a not so bright representation, but basically on the top you have kind of like the cognitive planning component where you have intent to speech. Then in your brain you're like forming the phonetic sequence that you need to produce. You then on top of that lay your kind of like the prosodic layer, the prosodic convolution of your phonetic sequence, so that you can change, and we're going to have a lot of examples on that. Like maybe you want to form a question, so you have to change the tone over the sentence, or you might want to express doubt, so you basically want to like raise your pitch at the end, and then you have to kind of like transform this information that the brain produces into muscular changes that influence the source, the voice source, which is basically the lungs and the vocal folds here, and the filter, which is basically what happens after the source. So the vocal folds are vibrating. That's considered the voice source still, and then whatever happens afterwards, like the larynx, the position of the tongue, the mouth opening, the rounding of the lips, etc. That's your filter. So that basically then changes the voice source in a way that you convey language. Just the voice source by itself doesn't sound very language-like. You can't really understand what a person's saying if you just listen to that part without the filter. And then you have vocalized speech at the end. And speech production, and we're going to get into one example there. Speech production is really, really complex, and it's really complicated. So it both involves the cognitive planning as well as the motor production, and these filters are actually quite complex. So there are many muscles that you have to change to produce speech. But still, speech production is like really fast, and we are really good at producing speech. However, some individuals have trouble with that, and we're going to get to this in a second. But before that, the vocal tract basically is set up in the following way. So you have the lungs and the vocal folds, which are your source. Then you have the mouth, tongue, nasal cavities, the lips, which are your filter. So basically, up to here, you have your source, and then all of this is the filter. This is basically a cut like here to the vocal folds. So we're gonna have a video that's gonna look at that right here. So this is how.
Do that soft.
So yeah, it's just to illustrate like how the vocal folds are vibrating. We're gonna talk about this in a little bit, but basically to access, and this is like falsetto, like high pitched voice and singing voices, but then you have these different voice qualities of like harsh voice that we had, that breathy voice, etc. And these are basically changes in the dynamics of how the vocal folds are vibrating, and we're going to get into some of these measures in a little bit. But before, let's talk about the filter, and I think the most important part of the filter, because it's also kind of like the most flexible part, is the tongue. And in most interestingly, like this, the tongue, like the peak position of the tongue, defines most of the variability of the vowels that we are uttering. And here you can see some scans, like from somebody who's doing an E, U, and ah, and and so you can try that out yourself a little bit, like try to feel where your tongue is going. And basically, what the tongue is changing is, so if you remember, like our filter starts around here somewhere, and now this is our, like this is the first like vocal cavity or vocal tube. So this is a pretty long one, but you can change the length of it by moving the tongue position like up here, down here. So you can change it in the length. So this part could still count a little bit, and then you have like some length here. So that could be very short if you move the tongue very forward. It could be a bit longer if you move the tongue quite a bit far back, and then you have some cavity here. And these cavities or tubes are called the formants. And basically the formants are defined by the length of these tubes, and the formants are resonance frequencies of those, and we're going to have some examples of that. But yes, also like apart from the tongue, you can also use the mouth opening to create other tones. And for example, you have some fricative sounds. So something like that, etc. And then you have nasal sounds, and where the mouth isn't open, and also stop sounds like etc. And I think, do we have that? Yeah, so we have, so there's a website with tons of examples here. We can go to that website real quick, and it's kind of cool. So you basically have a lot of different types of sounds. You can't really see it. Let me check. Let's see if we can see. Here's some, and you have it in different like languages too. So so these are Hosa like click sounds. I don't know.
Ukutola. Ukutola. Ukunola.
So like this click in there is part of Hosa language, and so we're not using that in mainstream American English. But yeah, so this website basically has tons of examples. This is from UCLA, so I'd recommend, like, if you're interested, you can explore this a little bit, get some good headphones, listen to some of those sounds. Yeah, and there, I think also on the phone there are some like IPA apps, like the International Phonetic Association apps, where you can like listen to the mainstream American English vowels versus I don't know, received pronunciation vowels in England or vowels in Germany and so on, so they sound a bit different from each other. Alright, so let's talk a little bit about some of the representations of speech, and because we kind of touched upon formants and fundamental frequency already, so, actually see that we should go into a break. let's do a break until like 9, and then continue here. I think it's a good point to restart. So like 6 minutes, 5 minutes, something like that.
I know the guitar wasn't working, but I see you're liking it. On your thing, it's always lit. On the little round thing, so you can tell that. But you know, I was like,